always take a film and project it in various theaters around the country because there was different sizes of sprocket holes, there was different widths of film, different speeds of projection. And so people in the industry got together and said, we need to standardize this stuff so that when we produce a film, we can show it anywhere in the country, or in fact anywhere in the world, and it'll fit on that projector and people can watch it and enjoy it. And so that's really, it was that standardization of film back almost 100 years ago that was the foundation for why the society was formed.
One thing I forgot to mention, just administratively, if you have any questions as we're going along, feel free to sort of stop us and ask some questions. We'll have a little quick question answer period after each presenter, and then we'll have some questions at the end, but also you can ask questions as we go along.
Great. So I see that some of my slides are actually a little bit out of order. We, as a standards organization, we have probably about 800 or 900 people, I think, involved in what's called the standards community, which is basically a group of people who are involved in some way, shape, or form in standards. And the committees, which I'll talk about in a minute, they meet 4 times a year. The most recent one was at Turner in Atlanta in December, and one of the things we did there was to have a user input session. We had 13 different presenters who talked, and they were users, so there was people from ESPN, there was people from Disney, there was people from Turner, from the BBC, and I forget who else there was, but there were people who were actually users of the standards who came and talked to us about what they need in standards, and this is a valuable thing. We've done this twice now, and it's always a great time of input and dialogue, and out of that, there's always been some new ideas for things that need to be standardized. One of the things that SMPTE has been doing recently is provide regular communications for their standards work. And so there's an outcome report from each one of these meetings. And it basically gives you a summary, probably 8 or 9 pages typically, of all of the work that has gone on in the previous meeting cycle. And there's a URL there that shows you where you can find that. If you just go to the main SMPTE homepage, under standards, you'll see a link which takes you to a page that looks like this, and then all of the meeting reports are there. So that's published quarterly. The most recent one for the December meetings was published a couple of weeks ago. Standards. Did you know that SMPTE was awarded an Emmy at the CES show? And the Emmy was actually for SMPTE's standardization work on high definition SDI, HD SDI, which probably most of us have some connection with, either strong or loose. In the industry, it's the foundational interconnect, has been for years in our industry, and it's also been the foundation over which all of the newer interfaces are also built. And we'll talk about that in a minute. If you're interested in finding a little bit more about that, there's a press release on the SMPTE site about that as well. Also, you may or may not know that SMPTE holds regular webinars on various topics specific to standards. So again, linking standards and education. And the next one of those is in a couple of weeks on the 4th of March. And it's about network media, which Lee's going to talk about here in a minute. Felix Poulin from the EBU, who's been very involved in that process, is the presenter for that. So, the standards community is, as I mentioned, is a group of 800 or 900 people, and it's organized into different technical committees. So we have, I'm going to bring my pointer, but there are the 2 green ones there are sort of the core ones, the essence, which is image and sound and the data that goes along with them. So all of the image format standards, the UHD-TV standards, the high-def standards, colorimetry, all of that kind of stuff is dealt with in the 10E committee. Also, all of the compression standards are dealt with in that. And then the companion to the essence is the metadata, which is data about the essence. And so 30MR is the committee that looks after registering all the different metadata elements that are used in our industry today. So those are sort of the two overall committees that spread right across the whole of the society. Then we have applications. So there are currently 4 application technology committees. So we have film, digital cinema, television and broadband, and cinema sound systems. And those committees deal with topics that are specific to those particular areas. So you can imagine, for example, that the film group, they're the people that look after those standards on the sprocket hole sizes. And they manage all of the standards, and there's still quite a number of standards on film. It's not as active a committee as some of the others, as you might expect, but it still is a very active committee. Digital cinema has to do with all of the theatrical stuff, television and broadband, that's very obvious. Cinema sound systems is a committee that was developed a couple of years ago to update some of the standards related to sound systems, specifically in the cinemas. And that's work that's very much needed and is progressing slowly, because they're trying to update a bunch of older standards, but they're also looking at some of the new immersive sound stuff in the theaters. And then there's 5 committees that are related to infrastructure. So we have file structures, so anything to do with files, MXF and AXF and MPEG 2000, and all of that kind of stuff is dealt with in 31FS. 32NF is the committee that I've been co-leading for the last 4 years, and basically it's the group that looks after all the interfaces and all the interconnects, ancillary data, and all of that kind of stuff. 33TS is the time and synchronization committee, and their mandate has been to develop a new time and synchronization standard. I think Paul's going to talk a little bit about that. That committee is currently in the process of being merged into 32NF, so it will, in a couple of weeks, be part of 32NF. 34CS is media control systems, and they basically are responsible for BXF, the broadcast exchange format, and the media control systems over IP. And then 35PM is the packaging group, and they're basically working on one project, which is called the forgotten the actual time behind that is the name. Forgotten the exact full name. Interoperable mastering format. Thank you, Paul. So those are the committees, and they people join those committees because they have special areas of interest. You can be a participating member or an observer member. Participating members are required to vote on the standards and be very active to attend meetings, and observing members can be active, but they're not required to be active in those committees. As Lee mentioned, I have been elected to the position of Standards Vice President, and just let me back up one slide. Overall, the top of all of these committees sits the Standards Committee. And the Standards Committee is a group that consists of the chairs of all of these committees, plus 4 or 5 other people who are invited to sit and manage how the whole standards operation works. And so they basically are the sounding board for issues that come along. They help decide what work goes in what committee and things like that. And so one of my jobs as Standards Vice President is to chair that Standards Committee, and that involves the general oversight of all the standards development. It's an elected term, a 2-year term like Randy's. So I'll see you in Palm Springs on the weekend. I'm responsible to the board for all of the standards work. So I'm not a governor, but I'm part of the Board of Governors in that role, and also part of the executive committee of the board. And one of the things that SMPTE does is have interconnects with various outside organizations, and So all of those communications related to standards have to be approved throughout the liaison process, and the standards vice president is responsible for communicating that. So that's a good segue into the next slide here, which is these are some of the organizations who are related to the kind of work that SMPTE is doing. And we have cooperative agreements with these and others. Sometimes we meet regularly with them. Once a year we try and have a joint meeting in Amsterdam at IBC. And we have liaisons that go back and forth from them as well. The SMPTE Digital Library is something that came into existence 2 or 3 years ago. The standards part of that library was added about a year ago. So there's 3 components to the library. The SMPTE Journal, right from the beginning, there's a copy of every version of the journal that has been published, and they're all searchable. The conferences, all the proceedings of all the conferences for the last 4 or 5 years are stored in the library, and each time there's a conference, those things get added. So those would be the annual technical conference and any of the society-wide conferences that are done. And then the standards. When I started doing standards work probably about 25 years ago, it was all done on paper, and so you had to buy standards, and you get a stapled 8 or 10 page thing in the mail, and that was your standards, and they were 3-hole punch, so you could put them in a binder and maintain them. And then they started publishing them in books, and then they started publishing them on CD-ROMs. And about 2.5 years ago now, they got rid of all of the CD-ROMs, all of the packaged media, and it's all online and all available through a subscription plan. So what that means is you don't necessarily buy a subscription to the journal or to the library, and then you can just go to the library, log in with your login, and you have access to all of the standards. You can search them, you can pull up the abstracts of them, you can download copies of those standards if you have a subscription to them in the PDF form. So it actually allows people to keep their libraries standards up to date. Question?
If I could add some input to SMPTE on that, I found that as being a very downside where you had to subscribe to the whole gamut of all the standards. If you're only interested in a small portion of them, you have to pay the big price to get the only thing you're mentioning. So you should come up with something where you get a subset and get a subscription to that, because it's been very daunting to.
Okay, I'll take that communication back, and we'll talk about that on the weekend, because we're having a meeting of our executive committee and our full board. That kind of information is helpful.
It made it very difficult to sell to my management to get a few standards.
Because of the cost of it.
Because of the cost of it, yes.
I think you can still buy individual standards.
I didn't see that.
I believe you can. Yes, he's shaking his head. I'm pretty sure you don't have to do the subscription thing. In that case, I think they're PDFs that you're buying.
That would be all right. I didn't see that option.
Okay, so this is just the home page of the library. And this is the home page of the standards part of the library. And as you can see there, you can browse by topic, you can browse by number. So one of the nice things is if you know that time code, for example, is you want to find out all the standards that have something to do with time code, you can put in a keyword, time code, and it'll pull all the standards out that have something to do with time code, and then you can browse the abstracts of them and search them that way. So it's actually much easier to find stuff. And you can also get access to older versions of standards. So as they get replaced, the old ones are not removed from the library, they're still available. Having said that, when the library was, the standards library was put into practice, they did not load all the old versions on. They started with a snapshot of what was current a couple of years ago. And the plan going forward will be to maintain the old ones. So I'll just go through these, or some of the search abstracts that come up like that. So standards participation, what do you have to do to participate in the standards? Well, as I said, the big groups meet 4 times a year, but the real work is done between the meetings. And all of the standards meetings have voice or web access. We use a system called GoToMeeting, which allows you to call in using VoIP on your computer, or there's always a dial-in number, and you can share desktop with the committee chair or with somebody else, and you can actually participate very, very well. So that's made participation a lot easier recently. It's obviously better if you can come to the face-to-face meetings, because you get a chance to see the people who are on your committee, and you can obviously accommodate or accomplish more in some cases, but the time is more limited because you're only together for a short period. So it's better to be there. You can participate remotely. Some people actually never show up face-to-face. They only participate remotely because of travel. We have people in India, for example, who participate in the standards work, and they find it very, very difficult to come to standards meetings because most of them are held in North America or Europe. But they still participate and are involved. Why should you participate? Well, if you're a user, maybe you would like the manufacturers to understand a little better what kind of things you need as a user. And if you're a manufacturer, you probably want to also understand what the users want, but you also want to participate and make sure that the stuff that your company is building complies with the standards, and you can give input to those standards. So probably, I'm guessing, Paul, what would you say, maybe 3/4 of the people, 2/3 at least, would be manufacturers representative, and the others would be user representatives. And there is a cost involved, so it costs SMPTE money to run the standards organization. So there's costs for the meeting hosting, there's costs to run the regular meetings, and so there is what's called a standards participation fee. It's $250 a year for individual members. If your company is a sustaining member, then there are sustaining members can have standards participants depending on the type of sustaining membership, and there are exemptions available from that fee depending on your circumstances. So if you're a retired person, for example, I believe there's a reduced fee and things like that. And Mauricio Roldan and Peter Sines are the two SMPTE headquarters staff who are involved in our standards, and they're always available to answer questions. Are there any questions before I move into individual standards about sort of the overall standards work? Randy?
I read, it was a while ago, Hans Hoffman in one of his articles was talking about how SMPTE would be looking more at, being in the marketing side where I come from. A lot of what we do is user case. You have an idea, technically you work out the feasibility of it, but then there's the business feasibility, user case. How is it going to be used? How is it going to generate revenue? I'm just wondering, is there going to be more of that kind of focus, as opposed to, it's not standards work for standards' sake, but the business behind all of that as well. So the idea that you would look at the user cases and that side of it as well.
I'm not totally sure how to answer that. I know that one of the SMPTE is a standards development organization, is not, they try to not set standards that are favoring one manufacturer over another, so that's why it's an open standards work. And having said that, manufacturers bring their technologies often to SMPTE to have them standardized because they want them to be widely accepted in the industry. And so that process involves dialogue and often changes in the standards improvements. A good example of that is right now GoPro, who was mentioned in Paul's presentation. Most people think of GoPro as the camera people, but GoPro have another side to their company, and it's the Cineform side. So Cineform and GoPro were two companies that merged about 2 years ago. And Cineform actually works in the professional space, making video codecs, compression technology that's used in Hollywood by the high-end post-production people. And their codecs were very well accepted, but they were proprietary to GoPro. So some of their customers said, we would like you to bring your technology and have it standardized by SMPTE. So they did, and they're now going through the process of doing that, and it's going to become VC5, a SMPTE video compression technology. Some of that is involving some changes, and they've agreed to doing that. So sometimes the business case is driven by a manufacturer coming and bringing something. SMPTE, Paul, you were going to comment?
Yeah, I was just going to add, when you said you weren't sure how to answer it, it's kind of a touchy area. SMPTE has to remain objective in its work. And because we're composed of those standards and users, we could, for example, manufacturers and users, we could have a bunch of manufacturers that all get together and say, we don't want to do 8K. We don't think 8K is any good. And if we listened to that kind of bias, users could end up not getting what they want and need because the industry has decided they can't get the margins they want, and they ganged up and decided they weren't going to do it. And there are mechanisms actually to allow for, what would you call an RDD? It's not a standard, but it's a...
An RDD is a registered disclosure document, so a manufacturer will bring their technology to SMPTE, they will declare it or disclose it, and SMPTE will not validate it, and they won't standardize it, but they basically make sure that there's enough information in the document to accurately describe it. And there are currently about 25 or 26 of those. Probably one that everybody would be familiar with is Dolby E. Dolby E is a proprietary system owned by Dolby. It is not a SMPTE standard, but the Dolby E metadata is RDD6. So Dolby declared what was in their metadata, how it's organized, all the different metadata elements and all of that stuff. And the companies that bring RDDs to SMPTE actually pay $2,500 to have their RDD put through the SMPTE process. So there is a mechanism for doing that.
And it's a way for a manufacturer to have a technology. Maybe they don't want a committee of people to look at it and broaden it and deepen it and turn it into something more rich. They simply say, we think, like Dolby, we think this is really useful to the industry. Here's what others need to know to interoperate with what we do. Not a standard, but it's a recorded instance of the thing. So somebody else now can do something that's Dolby E compliant with the state that it is, without Dolby going through the pain and delay of the standard. The standards do tend to look at every angle and make sure they're just right, and that can take time. So there are methods for people to commercially put things into SMPTE without violating the standards process or having to suffer the pain of the standards process. So we try and keep it floating above board at all times. So we have this out for people who simply want to document what they do and move on with life.
Any other questions before I move on? Yeah.
So how does that relate to 21:9 aspect ratio?
That's a real good question. 21:9, that sounds like 5K to me. It's a little bit bigger than 4K.
What's 3K then? Sorry.
Or maybe it's 3G. I don't know.
So I have no idea what image format's going to fill a 21:9 screen. To be honest.
Paul was talking about a CS on the TV.
Yeah, so I have no idea what kind of pictures they're going to put on that to fill it.
So somebody's got some standard, I guess, but it's not.
It's not a SMPTE standard, or maybe a computer standard for
Clip the
image
number of
formats.
scan lines and keep the width.
Right, I mean, there are other image formats that are not SMPTE image formats. You know, if you've been using a computer for very long, you remember there's, you know, VGA and XGA and WXGA and WXGA and all these different formats that the computer industry developed for different screen sizes, and they were particularly related only to that screen size, but they weren't universal across the way. Question over there, comment?
If you do the arithmetic on that, it comes out to about 2.33. which is pretty close to 2.35, which is CinemaScope. So, you know, that's the width they're looking at CinemaScope, and I guess the question would be really just to juggle around any of the MPEG standards to put enough blocks into it, and you could create a standard that would support CinemaScope.
Right, so one of the things that Paul mentioned in his little talk was the CES people confuse the terms ultra-high def and 4K, and they use them interchangeably. And 4K is a SMPTE standard image size. It's actually an image size container. So the container is 4096 pixels wide and 2160 lines. And then different image aspect ratios fit inside that container. So it's used for cinema formats, 185, 235, 240, they all fit inside that space. They don't fill it, so the 235 ones are like a letterbox. And I guess the 21 by 9 is intended to fill that out fully, perhaps.
I guess the 21 by 9 is good for that curve of the screen. So.
Yeah, obviously on a long screen like that, the curve would be helpful. It'll be interesting to see if that topic comes up in our March meetings in a couple of weeks. Which brings me to the next slide. We have the very fortunate situation, which is happening the first week in March, that the SMPTE block meetings, as we call them, are right here in Ontario. In fact, they're down in Niagara-on-the-Lake, right at the White Oaks Inn, which is right on the Queen Elizabeth Highway at St. Catharines there. So SMPTE members are welcome as guests of those meetings. There is a standard of, or an agreement for confidentiality that you have to sign to attend those meetings, but you can come and sit in and observe. And if you're interested in getting more information, see me about that at the end. My contact information is there. This is the third time in the years that I've been involved that they've been here in Ontario, sponsored by SMPTE, which is the former Genom company. So let's move into some of the standards. Let me go through these quickly. A lot of this is probably similar or familiar information. Large images need higher data rates to move them down wires. And with the proliferation of higher image pixel counts and higher frame rates and higher pixel depths, all those things add up to higher data rate interfaces. So last year we talked about multi-link 3 gig interfaces and the need to maintain compatibility with our current infrastructures and yet provide mechanisms of expanding that bandwidth to handle some of these. So there's a suite of 6 standards that have been developed, 2 single link, 2 dual link, and 2 quad link. And they basically are all built on the standard ST425 3 gig standard, which again is built on the HDSDI one that SMPTE got the Emmy for. So this is the list of them. I'll just, there's basically 3 of them that are for carrying single images, and there's 3 of them that are for carrying stereo pairs of images or 3D images. So the first one, 425-1, is what used to be called 425. So it's the foundational document. It's for carrying single images that have payloads of approximately 3 gig. So things like 1080p 5994, which is one of the things that we're familiar with, or 1080i in a 444 format, which takes the same bandwidth. It's those kinds of signals that fit on the 3 gig. 425-2 is a little bit of a strange beast because it's for carrying stereo pairs of 1.5 gigs. So stereo pairs of either 720p or 1080i. Again, they fit on one 3 gig link. -3 and -4 are the dual link ones. So -3 is for single images that are about 6 gigabits of bandwidth. So 1080p 5994 444, for example, or ultra high def at 30 frames in a 422 format. And then -4 is for stereo pairs of images of the 425-1 images. So 2 3 gig images, basically one goes on each wire. And they are identified as left eye and right eye, and they're identified as being a pair of images as opposed to being just 2 images on a wire that you can't figure out which is the left and which is the right. 5 and 6 are the 2 quad link ones. So 5 is, again, single images that are approximately 12 gigs. So those are ultra high def or 4K up to 60 frames per second at 422 or up to 30 frames at 444. And then the -6 is stereo pairs of the 425-3, again, 2 3 gig bandwidth images, two wires for one and 2 for the other. So how do we fit all the images on those wires? Well, basically, the way they work, they all work the same, and I just put one of the pictures up here. The main source image is divided into 2 images or into 4 images, and then that image is mapped onto either 1 wire or 2 wires, depending on the situation. So if it's a 1080p 61, for example, then if it's 444, some of the RG and B go on 1 wire and the rest of it goes on the other wire. If it's ultra high def, there's another picture here. If it's an ultra high def one, which has double the spatial dimensions in each dimension, it gets divided by taking pairs of pixels. And so all the yellow ones end up in one sub-image, and all the blue ones end up in the second sub-image, and the green and the pink. So you get 4 sub-images, and if you see the way that it's done, it's basically a pixel decimation. So you end up with 4 lower resolution, and by lower resolution, they're HD resolution, sub-images. So each one of them contains the full picture, and then those images are multiplexed together onto the wires. So that's the concept behind all of these interfaces. You take the image, you break it into pieces, you put them on the wire, and then you multiplex them together, depending on the number of wires that it takes. And in the case of the 444 Ultra HD, you do both. You do the pixel subdivision, and then you have to break the RGB apart also, so you have to do one first and then do the second one. That's why it ends up with the 4 wires. So, people saying, why would I want 4 wires, 4 3 gig wires? Why can't I have 1 wire? So, newer technologies have been available now for the last year or so that allow us to run coax up to 12 or even 24 gigabits per second. And so we can get economical interfaces running at 12 gig over 100 meter lengths on coax, and we can now take those 4 3Gs, put them on one 12G, and you have 1 wire to worry about. So currently, this is some of the new work that's been developed in the last 6 months. There's work to take all of the stuff that was done in those multi-link 3G things and to put them together onto single link interfaces, either 6 or 12, so that the dual link 3G ones go on the 6 and the quad link ones go on the 12. And that allows us to take the stuff that I just talked about and put it on 1 wire. But the stuff that we did in 3G still doesn't handle all the interface formats, because we have Ultra HD at 60, at 120, at 444 at 120, at 12 bits at 120. And so if you start doing the math, you start running out of bits very quickly. So 12 is not even enough. So these new interfaces are designed in a way that we can have single, dual, quad, 12G. And then as the technology becomes available and more affordable to get, say, 48 or even higher data rates, then the technology is designed to be scalable so that they get multiplexed together on the 1 wire and reuse the infrastructure, reuse the packaging, So the mechanisms are the same mechanisms that were used way back in HDSDI, but they're just being reused and scaled as the interface requirements become higher. I think if you go to the 8K ultra high def at 120 frames per second at 12 bits, I think you need about 140 gigabits per second, something like that. Anyway, it's a lot of pixels and a lot of bits going down the wire. So there is optical interfaces and electrical in this new format, and these will be coming out probably sometime this year. You'll see them. It's 208.1 is the 6 gig standard, and 208.2 is the 12 gig standard, and there's multiple parts, one for the formatting and one for the actual electrical and optical interface parts of it. So again, this is just the underlying mechanisms. Divide the pictures, multiplex the stuff together on the links, depending on the bit rates that are available. And the technology that's being used here is technology that's fairly mature from the datacom industry, so it's relatively inexpensive compared to some of the other technologies that are available at those data rates. And that's the multiplex there, the 4 different colors. RP219 is the color bar signal that most of you have probably seen if you worked in a high definition plant. And I talked about this last year a little bit, but let's update you on what's going on with that. So this is the different components of the color bar. And in these two regions here, in here, they've added some new components in the black and in the white. And what they've done is, rather than having flat field black and white, we've added what's called a valley and a peak. So it's a black region. If you know how HDSDI is encoded, black is not at 0. It's at 64 hex. And so there's a bunch of bits below that which sometimes are cropped off by systems and you can't tell because it's below black. But you need to know, because of excursions, overshoots and undershoots, whether that stuff is getting through. The same thing, white is not at the maximum value, but it's down below the maximum value. And so CBS actually developed this system, this signal, I think 5 or 6 years ago. And at Evertz, we actually made a signal for them, a custom signal, and then they came to SMPTE and asked Evertz to participate in standardizing it. So basically, this is what happens to the signal. This is the valley, so it goes down to the very minimum value you can get, and the white one beside it goes up to the very maximum value that you can get without getting into the reserved codes. And so you can see if on a waveform monitor, if your system's not passing it, then it'll get clipped. It'll be flat on the top. But you should see a nice linear ramp up and a linear ramp back down again. So that work has finished its ballot now. It's in the final stages of comment resolution. We're hoping next week to have a final comment resolution meeting and hopefully get it approved as a draft publication. Unfortunately, we won't make it in time for March, but we'll get it hopefully by the end of March. It'll be ready to publish. Some of the other things that are going on in our 10E group, there's a bunch of work that's been going on now for quite a while to standardize the parameters for reference displays. For years, there were SMPTE reference display monitors that were CRT based. And as we all know, there are no CRTs that are being manufactured anymore. And with all the fixed pixel matrix monitors, the FPM monitors that we have, whether they're plasma, LCD, OLED, whatever, there is no standard for how those reference monitors need to be calibrated. So this work was set up to define the technical parameters for these reference monitors and the viewing environments so that program interchange can be done so that facility A can set the colors on their programs, and they can view it in other facilities, and they'll get the same results. So there are currently 6 documents that are planned. The SMPTE standard will be 2080, and the first one they're working on is the white reference. So there's never been a really good definition of what is white, and that's fundamental to setting up the monitor, is knowing what white is. So the white reference standard has been through ballot and is in common resolution now, and I think it's almost ready to publish. There will then be a calibration and measurement RP that tells you how to calibrate the monitor. There will be a standard, again, for the reference display itself, and one for the viewing environment, and there'll be an engineering guideline that helps explain it all. ST125 is an old SMPTE standard. It's been around since the late 80s, I guess. It's the foundational document, if any of you were involved in the building of the CBC Broadcast Center, which was the first digital plant in North America, was it, Paul? You were part of that process. And it was built opened in 92, as I recall. 91, 92. So this is the foundational document that standardized all that stuff that was our standard definition digital component stuff. So it's an old standard. It's been revised, and it sort of grew into a collection of standards that involve different aspect ratios, 4:4, 4:2, and even 16:9 aspect ratios, which were used in Europe. And so the new version of it has brought all that stuff into one standard now, and it's replacing the old 1995 version, so that's the last time it was revised, almost 20 years ago. ST267, which is the 16:9 standard def, and RP175, which was the dual link version for 4:4. All that's in the same standard now. And that has now been published. It was published about a month ago, I believe. The revision work took about 6 years. And that's partly because it got diverted a few times by other things that were deemed to be a little more critical. But it was a huge job to bring all that stuff together and document stuff that wasn't documented properly before. This is some new work that's going on in 10E. Fundamentally, at the basis of all of our viewing is an electrical optical transfer function. So basically, you feed an electrical signal into a viewing device, it changes it into light, and the mechanism or the function that relates voltage to light is foundational to the monitor and the calibration and all of that stuff. And so this work is trying to define a new electrical-optical transfer function that's based more on human perceptual, how our vision works, a little closer than the old versions of EOTF that are probably 30, 40 years old from the old CRT days. And this work is just getting started. So those are the kind of things that are being done in the 10E. This is a group that SMPTE's been participating in, and it's a task force that's being sponsored by the National Association, it's NABA, it's North American Broadcasters Association, of which our Canadian broadcasters are part of. In fact, the NABA head office is right here in Toronto. So this joint task force is, let me back up, get it right. It's the Task Force on File Formats and Media Interoperability. It's a very big, long handle. Their scope is to gather and analyze the requirements for machine-generated and readable file interchange and delivery in the professional media industry, and then based on the user requirements, and this, Randy, is maybe part of the answer to your question. This is users now who said we need some help in trying to standardize file format interchange, and part of that is based on the fact that you used to be able to say, this is the programmed file, we're going to play it out, we're done. The problem now is we play it out, but we have to send it out in 17 million different formats because we all have iPhones and iPads and Androids, and we have various different types of output formats that all have to be generated, and it's hugely labor intensive to do that. So they're trying to get a common format for file interchange that facilitates the script-driven mechanical generation of those outputs. And that will bring greater efficiencies and cost savings in interoperability to the file-based workflows. These are the sponsoring organizations: NAVA, AMWA, which is I've forgotten again what some of those acronyms stand for. SMPTE, IABM, which is the International Association of Broadcast Manufacturers, EBU, which is the European Broadcasting Union, and the ADID people in the US. There are 4 working groups, one that's working on user requirements, one that's working on file specifications and analysis, one that's actually working on reviewing the standards that exist today, and the 4th one is actually going to generate a report. What are they going to output? Well, they're going to document the user requirements. So what are the user requirements for this file interoperability? And then they're going to analyze what's available today to get us there. And then they're going to do an analysis, and based on that, recommend any future activities in terms of standards work that needs to be done. So this is the last thing I want to talk about. This is sort of an interesting thing that SMPTE was presented with last fall. Lee, I'm going to ask you to come up and drive this for me. When I first heard about this, I thought, what in the world is tactile excellence? Yes. I'll actually come back to it when I'm done with the video. So I got a little video to play here, which talks a little bit about the technology.